So I have the machine up and running. I've installed TrueNAS on it. Okay, so if you guys want to install TrueNAS, you can go to TrueNAS.com and download TrueNAS. There are two versions. One is TrueNAS Core, and the other one is TrueNAS Scale. TrueNAS Scale is Linux based. I'm more familiar and more comfortable with Linux, and that's the reason why I chose this. And I created a USB key. I booted from that, and then I installed TrueNAS. I'm not going to get into the actual implementation or the installation. You guys can find that. There's several videos on YouTube if you do a search. So I also tried Zima OS. Zima OS is not going to work for me. So basically what happened was I started the video, or I started doing the Zima OS implementation or installation, and it wouldn't detect the 10 gig NIC on the QNAP add-in card. And it also wouldn't detect any of the NVMe drives. So that's out as an option. I will look at Casa OS, I think, and see where that is as far as compatibility with this system, just to check it out. But for now, we'll stick with TrueNAS. TrueNAS basically is going to be what I'll be using more than likely, 90% sure going forward. So I've installed it. It's connected to the 10 gig NIC. On my Flex, my Ubiquiti Flex 10G switch here in my office. My PC is not 10G to that switch, it's 5 gigabit using an add-in adapter through USB-C. So I have 5 gigabit connectivity through the switch to that NAS, so that's a limitation there that I'm going to look at solving here very soon. But at the very least, I get 5 gigabits of throughput. There's overhead to that since there's a USB-C to TCP/IP TCP/IP translation there, and so there is some overhead to that. So it won't be quite full 5 gigabit speeds that you would typically get on a true network interface connected to a PCI port. All right, so here's TrueNAS. I created an account. This is me logging in for the first time here, and we'll go and configure and set it up. I'll walk through the interface. So I'll make this bigger so you guys can see it. So essentially here you have your TrueNAS system. You can check for updates. The platform is generic. It's not a TrueNAS supplied system. IX Systems is the vendor that creates TrueNAS, and you can actually buy NAS platforms, hardware and software, that are validated and sold through IX Systems. The beauty about that is, there's a configuration file built within the implementation of that, where it actually shows your device, the drives, the drive sleds. You can actually enable the identification LED on the sled if you have a drive out or need to replace it. So there's more integration into the IX Systems hardware if you go down that path. But you can also use it, the software only solution, which I have, and of course my platform is custom, so it's generic. Here's the version. This is the latest LTS release of TrueNAS Scale as of time of this video, which is February 16th. And TrueNAS is the host name. It's actually Stornado is the host name. I'm not sure why this hasn't updated yet because I actually went in and updated it. The uptime has been 17 minutes. If you need help, right, gives you links to the documentation site, the forums, and there is a monthly newsletter you can actually go to. Over here, you're getting some of the metrics and from your hardware. Here's the CPU. You can see here I have the 13th gen Intel Core 13900HX, 24 cores, 32 threads. So what that means is I have 8 performance cores and 16 efficiency cores. The performance cores are hyper-threaded enabled, but the efficiency cores are not. So if you add up the total threads, you get 16 threads from the performance cores and 16 threads from the efficiency cores, giving you a total of 32 threads. Again, very powerful system in such a small footprint. It gives you thread utilization, usage, and temperature of the CPU. Now here's the memory over here. We will talk about a little bit about this. There's a great article that, or a great video that Techno Tim just did on this subject around TrueNAS and how he has it set up, and he explains what the system memory is used for. Generally speaking, ZFS writes to memory first and then destages into your Z pool or your Z pool, right, which is your basically your extent store, right? Your capacity tier. And so you want, enough of that caching mechanism, right, to be in place to give you that ultimate performance, right? So really, you're looking at, what is typically your biggest write before the memory runs out, right? And obviously you're writing directly to the pool, and that could become a bottleneck. In my case, I'm not as concerned. I'm using NVMe, very fast NVMe on Gen 4. Again, these are Gen 4 HP FX 900 Pros, 4 terabytes. They're capable of around 7,000 megabytes of reads and around 5 to 6,000 megabytes of write. So it's pretty fast. And then you have your network interface here. I have 2 network interfaces, but I only have one that's connected right now, and I'm using the 10 gig on the QNAP add-in card, right? So that add-in card has 2 NVMe slots that house the Optane drives that I use for the actual, they're mirrored, used for the actual TrueNAS installation. And then there's a 10 gig port on that same card, and that's what this is. You can see here I have 10 gig here, and this is my IP address, and it actually shows you your traffic. So next we'll go into storage, and we're actually going to create what's called a pool. So you have to actually create a pool first, then you'll create a data set, right, which is basically volumes, and you create shares from that. So let's start with the storage. We'll create a pool, and this will walk you right through it. So I'm just going to call this Mike share, or M share for Mike. And I'm not going to enable encryption now because this is just a test, and if I was not testing, I would enable encryption. So I'll hit next here. You can see here that there are 4, the bottom right hand corner, there are 4 unassigned disks. These are the 4 NVMe HPE FX 900s that are on the motherboard themselves. So again, booting from the Optane drives, right, which are in a mirror for this ZFS, or excuse me, this TrueNAS scale installation, and the storage disks are all on the motherboard, and there's 4 slots in this motherboard. It's one of the reasons why I chose it. And now I have 4 slots I can leverage. This is my temporary setup right now. So the layout I'm going to use there's many different layouts, and this gets a little complex because of how ZFS works and how you expand the pool. So again, if you follow Techno Tim's latest video, and I'll link it in this video above as I'm talking now, basically he's going to talk to you about what's the easiest way to expand a ZFS pool. 'Cause it's not just like adding a disk. So one of the things I'll tell you is it's a little bit different than like a NAS using a different file system, like a ButterFS, like Synology uses, or something like that, or a Unraid where I can just add a disk, expands the pool, etc. It's not that simple. ZFS works differently, and so when you add disks to TrueNAS, you have to add them in the pool size, right? And that's what makes it complex, because if you just needed to add it 1 disk, right, that's very, very difficult to do, right? So in my case, I'm going to talk about RAID Z because this is what I'll be using. You can do a stripe. Obviously, I can stripe all the disks, and that has 0 redundancy, but gives you the best performance, right? I can mirror, right? So I can mirror the disks, and I can basically have duplicates from disk to disk for a mirror. I could do a RAID Z1, which is basically parity, 1 disk. This can accommodate 1 disk failure. You can probably compare this to a RAID 5. RAID Z2 is RAID 6. RAID Z3 is additional capacity. You can accommodate 3 drives. So 1, 2, 3 drive loss. Okay. And then there's DRAID, right? So DRAID is a ZFS feature that boosts receiver speed and local distribution due to a fixed strip width, right, for disk efficiency. So it may be substantially worse for small files, but you would opt for this over RAID Z when handling large capacity drives in extensive disk environments for enhanced performance. So basically large file size, large capacity drives. I don't have that. I only have 4 terabyte. If I was using something like 20, NVMe disk can get up to 60 some odd terabytes now, which is crazy to me, right? So I think it's 64 terabyte drives now, or 62 terabyte NVMe disks, which has superseded HDD size drastically because of the fact that they can pack more memory in such a smaller footprint, more capacity, whereas spindles, right, you have to worry about heads and actual platters, and making sure those platters are optimal and they're decently fast and they have enough cache on the front end. That's why you see these newer technologies like helium-based drives and things like that in the higher capacity storage. But they're still slow, right? When you compare it to, SSD compared to NVMe, it's extremely slow, right? So again, I'm going to do a RAID Z1. RAID Z1 will allow me to choose one disk, right? Retain three disks for storage capacity and one disk for basically parity. But I'm going to do a manual so I can show this to you, what a manual VDEV looks like. So I'm going to add a VDEV, and I'm going to drag my disks into the pool. And you can see here what happens is all the disks are now in the pool, and I now have 11.17 terabyte estimated usable raw capacity. Okay? Because if you think about it, 3.73, 3.73, 3.73, it's not counting one disk, right? That's what gives me the 11.17 terabyte. So I'll save this selection, and I'll hit next. And here's where you can have a ZFS log device, which basically can improve speeds of the synchronous write. So what is this? So the log device, right? For all intents and purposes, what happens is when you create a pool, okay, there's something called a ZIL, which is the ZFS intent log. And so all writes hit that ZIL and then destage from that into your pool, okay? And some folks don't like to have ZIL in the same pool that you're writing data, right? So if you think about it, ZIL sits in the same pool. And if you have a log device, that log device can sit outside of your pool of storage. And you could, make it very extremely fast, right? You can have NVMe, you can use an SSD front-ending HDD, right? And now your ZIL is basically, right, or I think it's called an S-log, right? Slog, right? Which is basically taking your ZIL and moving it out of the base pool and putting it on a separate disk media where you can write to that, and then it actually writes to your storage pool, your main storage pool. I'm going to skip this, okay, because I don't need this because I have very, very fast NVMe. I don't have enough capacity for a spare, and I probably would not use a spare in my case. If I had larger disks, right, maybe a larger platform with many HDDs, I probably would have a hot spare available to me. So this is L2ARC read cache, right? So this is basically things that can be accelerated using fast devices to accelerate read cache. Again, I don't need this because I'm all NVMe. If you're HDD, you may want to consider something like this. Again, this has to do with ARC. Okay, when I talked about memory and how much memory you want to associate to your pool, to your ZFS pool, this is what we're talking about. If you run out of memory, you want to have some capacity from a reads perspective, right, to be able to accelerate that. And again, you may want to have that in a higher performance tier like an SSD or an NVMe tier. Again, same with metadata, right? Very good to speed up small block I/O. I don't need this again because I'm using all NVMe. So again, this is typically not what you see on the forums or in YouTube when it comes to how people use TrueNAS. Generally speaking, most people use TrueNAS in a large storage pool and they're front-ending that with a lot of memory, right? And they are implementing, log caching mechanisms, etc., because they're using spinning disk. I am not using spinning disk, and therefore I don't need this. And I will not be using dedupe because, again, this is a test. So let's review this. And I'm not going to inspect the VDES. I will create the pool. Let's hit confirm. And now it's creating the pool right now. Okay. So now the pool is created. Okay. And we have a data VDEV, RAID Z1, 4 wide, right? Each 3.73 terabyte disks. It's not terabytes, terabyte actually. There is no metadata, log, cache, spare, or dedupe VDEV. Okay. The usable capacity ends up being 10.69 terabytes. I can look at my disk space reports. Okay, I can look at my I/O, right, per drive, which is nice. So you get a lot of telemetry data too built within TrueNAS scale, which is really, really nice. Let's go back to storage. You can also auto trim. Okay. So if I want to enable TrueNAS to review the data blocks, identify empty blocks of obsolete blocks that can be deleted, I can actually auto trim if I want. I can also do a scrub task. Okay, so if I want to set up a scrub, right? Basically, it's a cron job in the back end. I can do a scrub task, have it run, my schedule, right, on my schedule, on my frequency, etc. Okay, which, I won't get into detail on that, but that's something that you may want to look at as well. In the disk health, right, what is the highest temperature, lowest temperature, what is your average disk temperature, your smart, right, view all your smart information. So obviously the disk is going to provide smart data back to TrueNAS scale to be able to tell you the health, right, if you have bad blocks, things like that. Okay. So we have a data set name, right? It created with the zpool, and it's called mshare. And now what we want to do, we have some data set details. And by the way, you can do share specific settings, but I like to do data set specific settings. Again, the link I previously showed you for Techno Tim's last YouTube video talking about some of the settings that he uses. Of course, I would use compression. Again, I don't have deduplication on. There's other advanced settings. Checksums, of course, you want to do checksums. Let's see what else here. Record size, you can change this to match your working, your basically your data structure to see how this would be more in line with what you're using it for, etc. So, okay, so now that we have the TrueNAS scale operating system stood up, everything's configured, we created our data set, as you can see here. We're going to go ahead and create a share. And so you can see here I've already created a share called files. Okay, and it's inheriting the data set details, right? So it's file system, sync of standards, inheriting LZ4 compression, etc., etc. And you can see here the path. Then you can see here the data set management. I don't have any quotas. There's no user quotas or group quotas. I could set this if I wanted to. And I can actually manage SMB shares. So what we're going to do is we're going to go into, first, we're going to go into credentials, and I'm going to show you what I did here. So I don't have a domain associated with this device yet. I'm not going to do that yet. For the interest of a easy authorization provider, we're just going to use local groups and users for now. So I created a group called family. Okay, automatically gave it a GUID ID of 3000, the name family, and I checkboxed Samba authentication. So I hit save there. So that group is now created, and I also created a user called Mshihi, which is basically the first initial of my first name and my last name, right? So let's edit that, and I'll show you what this looks like. So again, I put my full name. It automatically creates a username on the first initial, last name. You can adjust this if you want. I created the password. It automatically creates a UID, and I associated the primary group with the family group I created previously. And because I am the administrator and I am the power user of this platform, I also added myself into the auxiliary groups of root and automatically built-in users. Okay. Then you can scroll down here, and you can see here you can get SSH passwords. You can choose to upload an SSH key. So if you want to SSH into the device with this account, you could do that. You can allow sudo commands. And of course I checkboxed Samba authentication again. And I didn't create a home directory, right? So I could create a home directory for this user automatically, but I did not do that. So let's get out of here. The next thing I did was I went into shares under Windows shares. And what you see, this is running here. this was not running before, it was actually off. So when I create my share, it's automatically going to start the SMB service and then ask you to have it start when the system reboots. And that's what you want, right? So if you have to go through an upgrade process and the system needs to reboot or need to reboot for any reason for maintenance activities, you want to be able to have these services up and running. So I created a share called files, all right, and I created the path of mount mshare files. Remember, the mshare is my data set, and the files directory is underneath that, right? That was created under the data set. You can see here mshare files. So I go back to shares, and I'll show you what that looks like just to show you. So I can go in here, I can choose my path, so I can do a subdirectory under files if I like, and call this or mshare, and I can call this test. Okay. As a matter of fact, I'm going to do this. We'll call this virtual disks, and that'll be for my virtual machines when we get into the VM section. I didn't choose default share permissions. I chose the multi-protocol NFS SMB shares. It's much easier. The POSIX compliant default share parameters, it's not great. It's very kludgy to work through to get it right. The multi-protocol NFS SMB share parameters, or the auth, right, is what you want to do. So I chose that, and then I went into advanced options. I didn't allow guest access. I didn't allow a host or deny a host. So this is good for creating an NFS share and allowing a host or a virtualization host to attach to an external storage device that's hosted on TrueNAS, where you can actually lock down, deny, and allow based on host IP address or host a DNS name, as long as it understands the DNS. And then you have these settings here you can actually do, or path suffix. So I'll cancel this and get to the view all here. So in the view all, I can come in here and edit the file system ACL. And you can see here I added the group family to allow, okay, basic permissions, basic, and modify permissions. And now that I have this group associated with this share, okay, I now should be able to access that. All right, so again, let's go back to the dashboard, and let's do this, and then let's bring up a File Explorer window. And what we're going to do is we're going to go to this path in Files, and you can see here I'm already in. Now, the only reason why I'm in already is because I've already provided the credentials, and Windows 11 cached those credentials for the File Explorer. And I have read-write access, so I can go in here, just create a folder, and you can see the new folder is created. And now I'm associated with that share. Now again, we're going to test this, and I want to remind you I have NVMe in my local machine, but I only have a 5 gig USB-C connection to my Flex 10G Ubiquiti switch in my office. And so because it's USB-C, you're not going to get true 5 gig throughput. There's some overhead from a translation perspective. Okay, so it's not like adding a network, a NIC, a 5 gig NIC into the device itself through a PCIe bus. We have to translate that over USB-C back to PCIe, back to TCP/IP. So there's overhead there, okay? And my NAS device itself is connected 10 gig straight, through a NIC to the same switch. So you'll see here when I send this almost 10 gig file over to the share, you'll see the speed will max out at my max settings of my device. So I'm not truly getting 10 gig, of course. I'm getting around 400 megabytes per second, which is around, 4 gig. Okay, so you lose that overhead from a networking perspective on my source, which is my workstation I'm on now, which is where I'm actually recording. But again, very fast. You saw there that it was very, very even, right? So let's send a couple files over. So we'll send these 3 files over at the same time and see what happens here. Very even speed. Okay, you don't see a lot of valleys, right? It's very even with the capacity of the networking. And what's funny about this, right, is that if I did have 10 gig on this, you would see a much better speed. You'd probably see some upwards of 800 plus megabytes a second to the NAS device. Because again, NVMe drives, right? Very, very fast. I can get, on one NVMe device, I can get 5 gig, right, of throughput a second on the NVMe device. So you can see here it's extremely fast, extremely even, and that's what I love about having the NVMe NAS. So I'm just gonna delete these here off the NAS share. Okay, so that is the basics of the NAS for now. You can see here the throughput, right, on my device, right, it was around, almost 3.75 gig